Hey guys, welcome back. In this problem, we are given a list of strings called words and a target string. We are also given a starting index. The list is circular, which means the end of the array connects back to the beginning. So if we move forward from the last index, we go back to the first index. And if we move backward from the first index, we go to the last index. Now, starting from the given start index, we can move either forward or backward one step at a time. Our goal is to find the shortest number of steps required to reach any index where the word matches the target string. If the target string does not exist anywhere in the array, we return -1. Let's simplify the idea. At any position, we have two choices. We can move forward or move backward. Because the array is circular, sometimes going backward might be shorter than going forward. So for every occurrence of the target word, we calculate two distances. One is the forward distance from the start index to that position. The other is the backward distance. Considering the circular nature, we take the minimum of these two distances. Finally, we check all positions where the target exists and return the smallest distance among them. If we do not find the target at all, we return -1. So in summary, this problem is about finding the shortest path in a circular array, where we can move in both directions. The key idea is to consider both forward and backward distances and pick the minimum. Let's understand the problem better with a few examples. First example. The input array is hello. I am LeetCode, hello. The target word is hello, and the starting index is 1. So we start from index 1, which is the word I. Now we need to reach any index where the word is hello. We have two such positions, index 0 and index 4. Now let's calculate the distance. First, go to index 0. If we move left from index 1, we reach index 0 in one step. If we move right, we would go through index 2, 3, 4, and then loop back to 0, which takes more steps. So the shortest path to index 0 is one step. Now check index 4. If we move right from index 1, it takes 3 steps to reach index 4. If we move left, it takes 2 steps. So the shortest path to index 4 is 2 steps. Now we compare both results. 1 step to index 0 and 2 steps to index 4. The minimum is 1, so the output is 1. Second example. The array is A, B, LeetCode. The target is LeetCode, and the starting index is 0. We start at index 0. The target is at index 2. Now let's calculate the distance. If we move right, we go from index 0 to 1, then to 2, which takes 2 steps. If we move left, because the array is circular, we go directly from index 0 to index 2 in one step. So the shortest distance is 1. That is the output. Third example. The array is I eat LeetCode. The target is 8. Now we check if the target exists in the array. There is no word 8 in the list. Since the target does not exist, it is impossible to reach it, so the output is -1. In this problem, we need to find the shortest distance to reach a target word in a circular array, starting from a given index. Let's understand how this optimized solution works. We first store the length of the array in a variable called total words. Now, instead of checking all positions separately, we use a smart approach. We iterate over a variable called distance, starting from 0 up to half the size of the array. Why only half? Because in a circular array, the maximum shortest distance between 2 points can never exceed half the size of the array. At each step, we check 2 positions at the same time. One is moving forward from the starting index, and the other is moving backward. For the forward direction, we use start index plus distance and take modulo with total words to handle circular movement. For the backward direction, we use start index minus distance, again with modulo to wrap around the array. At each step, we check if either of these positions contains a target word. If we find the target in either direction, we immediately return the current distance. This works because we are checking distances in increasing order. So the first match we find is guaranteed to be the shortest. If we complete the loop and do not find the target anywhere, we return -1. This approach is efficient because we check both directions simultaneously and stop as soon as we find the answer. Let's run the solution with the examples. Yes, the solution passed all the test cases as expected. Let's submit the solution and you hug the solution past all the test cases. That's it for this problem. We solved it using a smart circular traversal approach by checking both forward and backward directions at the same time to get the shortest distance efficiently. If you found this explanation helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more daily LeetCode solutions. Keep practicing, stay consistent, and I'll see you in the next video.